Good day everyone, my name is Rakishna Alakijaraman. My metric number is 01DKP 23F1045. Today I'm going to describe the function of stern frame. So what exactly is a stern frame? The stern frame is the main structural framework located at the aft or rear end of a ship. It's essentially a strong, rigid structure that provides support and more stability to some of the most vessels. One of the key roles is that it supports both the rudder and the propeller. These are vital for steering and propulsion, and without a strong stern frame to hold them into place, the ship would not be able to maneuver safely or efficiently. The stern frame also connects the after end of the keel with the stern post and the hull plating. You can think of it a linking framework that ties together the bottom and the rear structure of the ship, giving it continuity and strength. In addition, the stern frame provides overall strength and integrity to the aft part of the vessel. This is crucial because the aft section experiences heavy force, and not only from the water flow around the propeller, but also from the vibration and load generated by the propulsion system. The stern frame helps distribute these loads and ensures that the structure remains safe and durable over time. Finally, it also acts the base for installing steering and propulsion system. So, without a properly designed stern frame, you would not be able to securely mount the rudder, the propeller shaft, or other essential equipment needed for the ship's movement and control. To summarize it, the stern frame is a heavy and rigid structural framework at the aft. It supports the rudder, propeller, connects key structure elements like the keel and hull plating, provides strength and integrity to the vessel rear section, and serves as the foundation for propulsion and steering system. So, even it's not visible when look at the ship from the outside, the stern frame plays a vital role in ensuring the ship can move, steer, and remain structurally strong at the sea. So these are the points we take from the reference that I have in this topic. That's all from me. Thank you.
A very good day everyone. My name is Toshan Alaki Nandakumar. My metric number is 01DKP23F1039. Today I will be presenting the structural function of the stern frame. The stern frame is one of the most important parts of the ship's aft structure because it connects and supports key components such as stern post, rudder, and propeller. Without a strong stern frame, the ship's propulsion and steering system would not function safely or efficiently. Let me explain the main functions one by one. So the main point firstly is support. Firstly, the stern frame supports the stern post, rudder post, and propeller post. These are essential for holding the rudder and propeller in position. Without proper support, the rudder could fail under heavy sea pressure, and the propeller might lose efficiency. This function ensures that all these critical parts remain secure and stable. Second, force transmission. Secondly, the stern frame transmits forces and stresses from the rudder and propeller into the hull. When the propeller generates thrust or rudder turns the ship, very large forces are created. The stern frame distributes these forces safely so that the ship does not suffer from local damage or cracks. Thirdly, the stern frame connects the keel, stern post, and hull plating into a single strong framework. This connection makes the aft section act as a solid unit with the rest of the hull, preventing weak spots that could otherwise form at the joints. Fourth, propeller shaft alignment. The stern frame ensures the propeller shaft is properly aligned. Correct alignment is very important to avoid vibration, noise, and machinery damage. If the shaft is even slightly misaligned, it can cause wear and reduce propulsion efficiency. The stern frame prevents this by keeping the shaft steady. Fifth, structural rigidity. And finally, the stern frame provides rigidity to withstand bending and torsional stresses. As the ship moves through waves, the hull bends and twists slightly. The stern frame makes sure the aft part remains strong and durable under these conditions. To conclude, the stern frame performs 5 major structural functions. It provides support, transmits forces, connects the framework, ensures propeller shaft alignment, and gives rigidity. Each of these roles is vital for keeping the aft structure strong and for ensuring smooth propulsion and steering. Without the stern frame, the ship could not operate safely at sea. Thank you. That's all from me.
Good evening, sir. My name is Dardas Analaki Basil. My metric card number is 01DKP23F1018. So I will continue this presentation from here. So this slide explains why the stern frame is not just a structural component, but also a key part of how the ship operates safely and efficiently. First, the stern frame plays a major role in steering efficiency. Since the rudder is attached to it, the stern frame needs to hold the rudder securely in place, even when the ship is traveling at high speeds or in rough sea conditions. A weak stern frame could cause the rudder to lose alignment, which would make the steering less responsive and potentially dangerous. Next, it ensures propulsion efficiency. The stern frame supports and aligns the propeller and its shaft. This alignment is critical. If the shaft is even slightly misaligned, it can cause vibrations, noise, and faster wear on bearings and seals. In the long run, this could lead to expensive repairs and downtime. Another key point is that the stern frame reduces mechanical stress. By transmitting the forces from the rudder and propeller smoothly into the hull, it lowers the strain on the propeller shaft, bearings, and the surrounding structure. This improves the durability of the entire propulsion system and extends its service life. The stern frame also provides resistance against the sea loads and vibration. When the ship is sailing through waves, the aft part of the hull experiences dynamic forces. A long-term frame helps absorb and distribute these loads, preventing damage and maintaining stability. So as you can see, looking at the image on this slide, you can probably see how the stern frame forms a robust, reinforced structure at the aft end. This visual helps us imagine the forces at play. The rudder pushing against seawater, the propeller spinning at high speed, and all the loads being transferred through this framework into the hull. Finally, we can say that the stern frame is essential for the safe operation of propulsion and steering equipment. Without it, the ship's ability to move and steer reliably will be compromised. It also contributes to the ship's overall stability and hydrostatics, ensuring that the vessel behaves predictably during maneuvers. So the next slide, we can talk about the references. So we got few references here. The first one is Biran A 2013, Ship Hydrostatics and Stability. The second one is Barras B. Deret, CDR 2013, Ship Stability for Masters and Mates. The third one is Tupper, EC 2013, Introduction to Naval Architecture. The fourth one is Taylor, DA 2000, Merchant Ship Construction. And fifth one is Browley K, which is year 1998, Controllable Pitch Propellers. So that's all from us. Thank you.